Hello, learners! Welcome to General Chemistry class. This is Ma'am Grace Perez, and together we will explore the world of chemistry in a more simplified way. Are you ready? If so, make sure to have your notebook and ballpen with you. Come on, let's begin.
So here's a kickoff for this course. We will learn about matter and its properties. But what do we really want to achieve by the end of this session? So it is important to set our objectives. We have 1. Know and discuss the different properties of matter, and 2. Use properties of matter to identify substances and to separate them.
But first, what do we mean when we say property? It's the characteristics, traits, and qualities that are quantifiable, meaning it can be measured. And these are very important because it helps us describe matter in a way that makes it easier for us to identify a certain substance among other substances.
Take a look. What do you think is this? Yes, it's a necklace adorned with gold sheets. But how is this possible for a metallic element to be turned into thin sheets without breaking? Which property of matter do you think is shown? Let us have another. What do you think are these? Well, these are copper wires. And one of its known use is in electrical wiring for electricity transmission and distribution. But have you ever asked yourselves also, how is this possible for metallic elements to be turned into thin threads without breaking? Which property of matter do you think is shown? We will all together find out the answers as we go along.
And to better understand our topic for today, let's have a short recap, starting with differentiation of the following: pure substance versus mixture, element versus compound, homogeneous versus heterogeneous mixtures, physical change versus chemical change, and intensive property versus extensive property.
Now, let us classify the following into pure substance or mixture. But before we answer this, we are going to differentiate first pure substance from mixture. All matter can be classified as either pure substance or a mixture. Pure substance is also simply called as a substance. All pure substances can either be an element or compound, and it is made up of single component, while a mixture is composed of two or more components physically combined. So when you try to combine two or more substances, you will form a mixture. However, all of the components in a mixture can retain its identity. For example, oxygen is a pure substance because it is an element. Water is a pure substance because it is a compound. While a cup of coffee is a mixture of sugar, coffee powder, and water. When we say retain its identities, that means the composition of water will always still be water, so as coffee powder and sugar. Though we may not be able to distinguish each of the component, but still we can detect and we can determine the identity of each of those components in a cup of coffee. Let's go back to the problem. Classify each of the following as pure substance or mixture. Number 1. Water. Water is a compound composed of two atoms of hydrogen and an atom of oxygen. Therefore, it is a pure substance. Soft drink. Soft drink is a mixture because it contains two or more components. It is made up of water, sugar, food color, and flavoring. How about bronze? Bronze is a mixture because it is an alloy of copper and tin. 4. Carbon dioxide. It is a compound of carbon and oxygen. Therefore, it is a pure substance. How about air? Air is considered as mixture because air shows the properties of all the gases present, and it can be separated into its components like nitrogen, oxygen, argon, and carbon dioxide by the process of fractional distillation of liquid air. How about mercury? Mercury is an element, right? Therefore, it is pure substance. This time, we are going to classify each of the following as an element or compound. But before we answer this, let us first differentiate element from a compound. All pure substances are either element or compound. Element contains one type of atom, while compound contains two or more types of atoms chemically combined. Let's go back to the problem. Classify each of the following as element or compound. Copper wire. It is an element. Its chemical symbol is Cu. It is commonly used in making electrical wires. Table salt. It is a compound. Its chemical formula is NaCl, and it is very known food seasoning. Baking soda. It is a compound. Its chemical formula is NaHCO3, and it is a common ingredient found in mouthwashes, deodorant, and teeth whitener, and also it could relieve itchy skin and sunburns. Hydrogen peroxide. It is a compound. Its chemical formula is H2O2, and it is a mild antiseptic used on the skin to prevent infection of minor cuts, scrapes, and burns. Oxygen. Oxygen is an element. Its chemical symbol is O2, and this is very essential for all living things for the process of respiration. But it has also industrial uses such as production of steel, plastics, and textiles, also in welding and cutting of steels and other metals. Now, we are going to determine each of the following if it is homogeneous or heterogeneous mixture. But before we answer this, we are going to differentiate first homogeneous from heterogeneous mixture. Mixture is categorized into two: homogeneous mixture, also known as solution, and heterogeneous mixture. Homogeneous mixture is uniform throughout, which means they represent the same composition and properties as a whole. Like for example, a cup of coffee. We may not be able to distinguish anymore the components that made up a cup of coffee. We may not be able to see which is sugar, which is coffee powder, and water. On the other hand, heterogeneous mixture is not uniform throughout. Example, oil and water mixed in the same container. We can still distinguish the two, which is oil and which is water, and that they have retained their properties and composition. Let's address the problem. Classify each of the following as homogeneous or heterogeneous mixture. Vegetable salad. It is heterogeneous. It is composed of different vegetable slices and leaves which are still distinguishable from other components. Rubbing alcohol. It is homogeneous. Rubbing alcohol is composed of alcohol, water, and scents. Stainless steel. It is homogeneous. It is an alloy of iron and carbon. Sand and gravel. It is heterogeneous. Sand and gravel are particles of sand and gravel of different sizes which can still mechanically be separated. Properties of matter are categorized into two: physical properties and chemical properties. Physical properties are those which can be observed and perceived with our senses easily. On the other hand, chemical properties are those that can be observed when substance reacts with another substance. However, physical properties are further categorized into two: extensive properties, those which depend on the quantity of sample, and intensive properties, those that do not depend on the quantity of sample present. Take this for example, a glass of water and water droplets. Obviously, they are not of the same volume, right? But as you have observed, both samples are colorless. Therefore, color is an intensive property because it is not influenced by the amount of sample present. While these samples are relatively small quantities of water, that's why they appear to be colorless. But pure water has a slight blue color that becomes a deeper green as the thickness of the observed sample increases, like in the ocean. The blue hue of water is an intrinsic property and is caused by selective absorption and scattering of white light. Let me give you another example of an intensive property. It is described as the ability of the substance to be stretched into thin threads or wire. Examples are strings of the guitar and wires inside the electrical connections or electrical wirings used for the electrical transmission and distribution. What do you think is it? Yes, you are correct. It's ductility. Here's another example of intensive property. It is referred to as the ability of substance to be hammered or transformed into thin sheet. Examples are jewelries, tin cans, and metallic roofs of houses. Do you have any guess? You got it right. It's malleability. Let me give you another example of an intensive property. It is the ability of matter to be scattered or spread out, like adding ink into the water. Take a look at this one. Do you have any guess what intensive property is this? You got it right. It's diffusion. We shall now move on to examples of extensive property. Focus on the base of this one time, how we will be able to determine if it is big or small. Of course, we are going to measure its dimension using a tape measure or a ruler for us to be able to determine its size. And size is an example of extensive property because it depends on the dimension measured or taken. On the other hand, we will be able to determine the amount of water poured into this glass by measuring its volume. And for accurate measurement, we can use the graduated cylinder. And that volume is an example of extensive property because volume depends on how much water is being poured inside that glass. It depends on the amount of substance present inside the container. We shall now consider examples of chemical property. And the first one refers to the ability of the substance to ignite and sustain fire, like in the burning of paper. What chemical property do you think is that? Flammability. Yes, you got it right. And flammability is the ability of a chemical to burn or ignite, causing fire or combustion. And that degree of difficulty required to cause the combustion of a chemical is quantified through fire testing. And usually, materials are rated as highly flammable, flammable, and non-flammable. Another example of chemical property is described as the loss of electrons during a reaction by a molecule, atom, or ion. Do you have any idea what chemical property is that? It's oxidizing property. You got it right. Well, iron is arguably one of the world's most important metals. It's relatively strong, lightweight, and malleable, making it an effective material for countless products. In its natural state, however, iron is highly susceptible to rusting. Over time, the versatile metal will become corrode, resulting in the formation of iron oxide, which is more commonly known as rust. Iron as well as iron alloys rust because of a chemical reaction known as oxidation. When iron is exposed to a moisture or oxygen, oxidation occurs. During this chemical reaction, iron is converted into iron oxide, and that iron oxide typically has a reddish, flaky appearance that becomes progressively worse over time. If left unaddressed, the iron oxide will spread, thereby jeopardizing the physical integrity of the iron. Let's have a drill. Determine each of the following if it manifests physical change or chemical change. Lighting a matchstick. It is a chemical change because it manifests combustion process. Melting of chocolate. It is a physical change because only phase change is occurring. How about this one? It shows water evaporating from the waterfalls. This means water changes from liquid state to gaseous state without altering its chemical composition. Therefore, physical change. However, in bread baking, yeast transforms the sugar in the dough into carbonic gas called carbon dioxide and alcohol called ethanol. The trapped carbon dioxide makes the dough rise, and the alcohol produced by fermentation evaporates during the baking process. Therefore, chemical change. Check if you are still doing good. Try this one. Categorize the following properties of matter as intensive physical property, extensive physical property, or chemical property. Answer this in 30 seconds. Your timer starts now. Time is up. Okay, learners, let's check how much have you learned. Number 1. Combustibility of plastic, its chemical property. 2. 5 kilograms of rice is as heavy as 5 kilograms of newly harvested cotton, its extensive physical property. Number 3. Water freezes at 0 degrees Celsius, intensive physical property. 4. Silver is tarnished when exposed to air, forming silver oxide, its chemical property. 5. coal is used to produce electricity by burning them to power the generator. It is chemical property. So, did you get it all correctly? Very good. And to reinforce today's session, I will leave you this as an assignment, and this shall be submitted next week. That will be all for this session. Do you have any questions and clarifications? If you do, don't hesitate to reach me via Messenger at Text Grace Perez, and also don't forget to involve yourselves in our group chat, GenChem, for more updates. I do hope that you have learned something significant today, and looking forward for more simplified discussion in this subject. Bye!